Champaign County Agriculture Today with your host, Dennis Riggs.
Hello and welcome to Champaign County Agriculture Today. My name is Dennis Riggs, your host for the next few minutes as we talk about issues that are of concern to not only you, but also to agriculture here in East Central Illinois. Okay, you got up this morning and you looked out the window and it was just a beautiful day here in your backyard, but the wind was kind of blowing and you went over and you opened the refrigerator and got the orange juice out and you turned the light on at the kitchen table. You saw energy at work this morning, didn't you? That's right. Electricity was running that refrigerator. Electricity, you turned on that light. But when you looked out the window, you also saw energy at work moving those trees around. That was wind energy. And today on our program, kind of a new thing around that there's a lot of action going on in Illinois and across the nation and actually across the world about harnessing the power of the wind for a clean, renewable fuel. There's good news, there's bad news, but it's all late breaking news, and you're going to find out about it today on Champaign County Agriculture Today. We have two excellent guests with us today, and we're going to talk about the issues concerning wind energy. We're going to start out with Bill French. Glad to have you with us today, Bill.
Thank you.
And Randy Winter. I'm sorry. I have to read my writing a little bit better. Sorry about that, Randy. Bill, let's start off. Give me your title, who you work for, and what got you into this wind energy business.
Yes, I work for a company called Midwest Wind Energy. We're based out of Chicago, but we develop mainly here in the Midwest, both Illinois, Wisconsin, Iowa, and Nebraska. And my title is a project manager. And I'm responsible then for finding suitable areas to develop wind in the Midwest. I will then work with the landowners on contracts, leases, and then take the project all the way up through what we would say was shovel ready. So all through permitting, whether it's local, county, state, even the federal government gets involved in many ways.
Is it safe to say, Randy, that your job, or Bill, that your job did not exist how many years ago?
Well, it's a fairly new industry in the Midwest. Obviously, wind has been developed out west in the California area for some time, but in the Midwest, it's probably been here for about 6-7 years.
Mm-hmm. The first wind generator, where, when, how long ago do you have? I know that's off the top of your head. Do you know approximately when that first thing was put in the air that harnessed the wind for power?
Oh, goodness. Well, obviously, most farmers know that wind has been used, for a century or so. Both either for pumping water, but in many cases back in the 30s, 20s and 30s, they were using them to generate electricity stored in their batteries and then use it to light their homes. So it's been along since at least that point in time.
It's been around, but you just got into it recently. Okay.
Yes.
Okay. Randy, good to have you with us today. You're bringing to us more of the academic side of this whole wind energy. Give us the title, your title, who you work for, and what got you into this business.
Okay, I am a professor at Illinois State University in our Department of Agriculture. So my background is agriculture. Grew up on a family farm in southern Illinois. I'm also an associate director for our Center for Renewable Energy, and that's kind of the hat I'm wearing today. About 4 or 5 years ago, a group of faculty members on our campus saw the interest in renewable energy, including wind energy and others as well. And we decided that the university needed to be on a leading edge to create a new major in renewable energy to prepare people for this expanding industry. And so I'm one of the faculty members that helps lead that initiative, in addition to coordinating the wind working group for the state of Illinois.
Now, that's interesting that institutions such as Illinois State would see this. Was that coming from the students? Was it coming from business? Or was it coming from inside the university?
Really, it was the faculty members themselves that led that charge. We saw the industry beginning to creep into the Midwest, and we just thought that it was going to continue to grow and become a pretty significant industry. And so, at that time, universities, community colleges were not very active in that area, and we saw an opportunity to really be a leader.
To be able to teach, you have to have those that know, such as yourself as a professor. Is that information coming from research? Is there textbooks out already about this, or are they deviations from other power production?
Yeah, there are a wide variety of sources. Of course, a lot of our connection is simply building relationships with people in the industry. You know, the people on the ground with their hands on the machines are the ones who really know what's going on. And so we have strong relationships with industry representatives. There are some good textbooks out there. that deal with various aspects of renewable energy. And of course, traditional energy has been around a long time. And really, we're talking about ways to modify how that energy has been produced, to find new ways, perhaps more economically friendly ways to produce some of that energy.
Well, we couldn't have a professor on our show without having some slides to show, and you can introduce those. So we're going to go to slide number 5, and this one is talking about energy itself. Now, what we're talking about is what a typical light bulb would use. Let's get some terms so people understand. If you would, Randy, here we're showing a typical light bulb. Give us watts per day. Give us an idea of what this means to the consumer.
Okay, the biggest area of confusion when people talk about energy and power is the difference between watts and watt hours, or kilowatts and kilowatt hours. Now, most consumers certainly recognize a light bulb and the idea of a 60-watt bulb, and that's a measure of how much energy it consumes. And if you run that light bulb for an hour, then it would consume 60 watt hours. Okay, so there's difference between the power and the energy. And so that's an area that's awfully very confusing to a lot of people. People pay their electric bill, of course, based on the kilowatt hours that they consume.
Basically the thousands, kilowatt meaning 1,000.
And that's 1,000 watts, yes. And as the slide shows, a typical house uses about 10,000
We'll go to slide number 6 here,
year.
pull that up. And a typical house uses quite a bit of electricity, quite frankly.
It does use quite a bit of electricity. You know, we take it for granted. You know, every day, as you mentioned in the opening, we get up and we hit that switch and we expect the electricity to be there. And it's really quite amazing to think about the tremendous fluctuation in demand for electricity and the supply for electricity, and every second those two things have to be matched for the entire country. It's really quite an amazing feat.
People don't realize that, you know, when they hit that switch, something's a whole mechanism, a whole industry has to be behind there ready to supply that power. The capacity to ramp up and ramp down is awesome. Tell me about, how do your students learn? Do they learn these basic things to get started, or where do they start as a basic in your program?
Well, that's an excellent question. When we introduced the program, we told our administration, so we will grow to 60 students in 4 years. So we will gradually grow this program so we can match resources to it. We opened the program a year ago last fall, and in the very first semester, we went to 60 students.
In the first semester?
Excuse me.
Yes.
And so that growth far exceeded our expectations and quite frankly, our ability to meet that need. But our program offers students 2 alternatives. We call it a technical track, which deals a lot more with the technology, kind of the science side of it. And we also have the business and economics track, because that is, of course, critically important to the success of an industry. And this is an industry that has a lot of policy impacts and certainly a lot of economic features. We have to compete with traditional industries such as coal and nuclear. And of course, if it's not competitive, it doesn't work.
Well, let's focus in. I'm going to bounce back to Bill here for just a second. We've seen that there's a demand. We've seen that we need kilowatts. We need to produce that electricity. You're, of course, hoping that a lot of that can come from wind energy. Let's bring up slide number 7. That's going to have a picture of your business, of what you do, and it talks a little bit about wind energy. Tell us what we're seeing here in this shot.
Well, what you're seeing is a commercial scale wind turbine that you would typically see here in the Midwest. It's approximately 256 feet to the hub, and to the tip of a blade it can be as tall as 400 feet, so they're very large, but we try to site them obviously in very compatible areas, which are in this area, farms and farm fields. A typical turbine is going to produce anywhere from, these days, anywhere from 1.5 to 2 megawatts.
And of course, mega being a million watts.
Right, that's right. Which, as you can see, can produce enough electricity by itself to power anywhere from 500 to 600 homes.
So one turbine up there, like we saw, of that size and dimension, How many homes again?
Anywhere from 500 to 600 homes.
If the wind's blowing.
If the wind's blowing, yes. And the wind here is, we're looking for about 35% efficiency out of each turbine.
Where are the wind generation stations? They're probably, Illinois, of course, is not the first place these have gone up. Are there others in the U.S. around that are up and running?
Oh, certainly. There's quite all over the Midwest. Out in northwest Iowa and southwest Minnesota, it's a very vast wind area up there. And so there's lots of wind developments that occurred in that area. Plus, you're seeing a lot in Kansas, and actually Nebraska is one of the areas that you'll see quite a bit more wind development also occurring.
Just like there's good areas for wind energy, are there areas where these absolutely will not work?
Oh, sure. You need to have an area where there is really three things occurring. One would be that you have wind, and we're looking for wind at around 80 meters that's going to be turning at about 7.5 meters per second. Mm-hmm. So that's 14, 15, 16 miles an hour. Second, you'll need proximity or location close to the grid. We can produce all of this electricity we want, but if we can't place it into the grid, it's going to waste. And then the third thing is you're looking for compatible land uses and landowners who would embrace having a turbine on their property.
Mm-hmm. Well, let's take a look a little bit closer at that structure. Let's go to slide number 1, and this slide we're going to take a look at the thing that makes it work. This is a turbine. You said, once again, the dimensions of it. Are there different designs? Are there different looks to a wind turbine?
Pretty much this is the look that you're seeing on a typical turbine these days. It has a central stem or a stand that it's on within a 3-blade nacelle. The nacelle at the top is where all the mechanics are held, and then it has a 3-blade design.
What I found out that I didn't realize that the post or the tower is actually hollow, mm-hmm. and access many times is up through the center of that. Is that correct?
It's always up through the center, yes. There's a locked door on the outside so that nobody can venture in on their own. And then there's a stairway up in there, and a technician will have to come in and actually climb up through the tower up to the nacelle. There's a trap door, and enters in and can then do whatever maintenance is necessary up there.
Who builds, this doesn't come from your local hardware store, who puts this type of information or this type of mechanics together?
Well, there's probably about a dozen companies doing that now. Some here in the United States, many from outside the United States, but some of the components are manufactured here locally, but most of them are shipped in from overseas.
Many times when you hear about wind energy, you don't just see one turbine, you see several of them. We're going to go to slide number 2 here that's going to show a little bit more of a little bit bigger area. What is the number? Does it take 2 to make energy, or does it take 200?
Oh, well, here you're seeing a wind farm. That's what we commonly refer to them as, but or a large development area. And these can be anywhere from 1 to 2 to maybe even 100 turbines themselves.
Is that the biggest number? Are there farms any bigger than 100?
No, there's some that go larger than that.
Really?
Some that go up to as many as 500 megawatts. And in further west and more in the central part of the United States, even larger than that. Panhandle of Texas has some that are maybe even 1,000 megawatts. Mm-hmm. So yeah, some very large wind farms. Now a 200 megawatt wind farm will probably use up anywhere a land area, probably 15 to 20,000 acres in total, but we're only using a small portion of the landowner's property. It's maybe in the end only 100 foot by 100 foot, or about a quarter of an acre, minus whatever access roads go there. So it actually turns out to be fairly minor land-intensive use when it really comes down to it, but it's usually a very large area because you need to separate the turbines from each other so they don't interfere with each other.
I'm going to slip over to Randy for just a second. We see this technology. We see these big, massive machines up there that are doing this tremendous work. In the short period of time that you've been watching this industry closely, what changes have happened as far as the design, the manufacture, or is it pretty much a mature technology?
No, it's really not a stagnant technology. There is constant pressure, I don't know if that's the right word, or motivation for the companies to build taller and larger machines. And so we've seen what used to be the standard in the industry was about a 1.5 megawatt machine, and then it went to 1.65 and 1.85, and now we're seeing 2 and even 3 megawatt machines onshore. And a future trend for wind energy is offshore. Of course, there's been a lot of controversy about the project off of Massachusetts, but now we're talking about turbines that are 5 megawatts in capacity. So they continue to get larger. in capacity, and there's also a push to get them higher and higher because, as Bill mentioned, it's all about capturing the wind. And one of the characteristics of the wind is basically the higher you go, the stronger the wind. And so there's a constant trend towards taller and larger turbines. And they're actually technological marvels. When you look at that, and it seems like a simple structure, but there's actually a mechanism that controls each one of those blades independently. And so there's a computer monitor that's tracking the wind, tracking the direction and the force, and constantly adjusting the turbine to maximize the power that they can generate from that by turning the blades a little bit and controlling their revolutions.
Could it be compared to like a pilot that's piloting an airplane can also control the pitch and the blade and the height and how fast they climb, how fast they go down? Is it similarities?
That's a very good analogy. Yes, it is.
Now, we see the fields with 50 to 100. What have you seen, Randy, as far as an individual, a farmer or a rural property owner or somebody putting their own up? Is that cost effective?
There's really different segments of this industry, and when you talk about these very large, what we call utility-sized turbines, as an individual turbine is not very cost effective because there's so much infrastructure that's required for that machine, and so it's economies of size. Why is a wind farm 50 or 100 units? It's because they can spread those fixed costs of development and connecting to the grid. When you talk about an individual farmer, there are what are called small wind systems that are designed to maybe provide energy for just one farm. And that's really a different part of the industry, an industry that's in a certain respect looking for identity. You mentioned the way these machines look. When you get into the small wind industry, you do see some very unique designs. People call them egg beaters, vertical axis turbines, some very strange designs. And as a consumer, I would caution people to be very cautious about looking at some of those things that maybe look very attractive, but perhaps don't generate much energy.
I understand. Well, I know, Bill, when we started the program, you talked about how on the farm, wind power has been around for some time, but not necessarily just electricity. What are you seeing? Are there other uses of wind power other than producing electricity? Of course, in your business, it's all electricity, right?
Well, yeah, that's certainly our focus. I really don't know if I can speak to what other potentials could be used for the wind, but certainly on this scale, using it to generate electricity is probably one of the more efficient ways to use it. Whether they want to use it to power their wells or do other things like that, I'm sure those opportunities are there. But certainly, I think the most efficient way to use it would be to generate electricity.
And Randy, how about you? Do you see other uses of the wind power, maybe in a mechanical use, or is it all alternating current like we have in our plug-ins in our house? Is it direct current like you see in a mobile power situation? Are there other uses also?
We talk about wind energy traditionally. Early uses of wind energy were for pumping water and for grinding grain and things of that nature. And as we mentioned, today the industry has really moved towards electrical generation. And so that's kind of the way that we're moving. I guess perhaps a more efficient way to provide those other services is by using electrical power. So maybe going kind of around the bend to get to where we're headed is the way to do it. And these large machines basically generate AC. There are a series of transformers. Of course, it's generating at a fairly low voltage, and it goes through a series of transformers that kicks the voltage up that then goes onto the big power lines for long-term transportation of that energy to the markets where it's needed, like Chicago.
Okay. All right, Bill, here we go. We've got wind energy. We need electricity. We figured out we need that to power that refrigerator and the light bulb in the morning. We found a way to do it. We can produce it with wind in cooperation with some of the others out there. How do you go about siting and figuring out where to put a wind farm?
Well, that's an excellent question. There are some sources out there where you can look at it on a macro scale and have a good idea of what the wind is doing. There are some companies that have done studies and they've accumulated some information out there, and that you can find that's generally found online. So that's the first thing you look for is where do you have some wind that you think you can to produce a wind farm. And then second is really to put your feet on the ground and go out and start meeting with the landowners to see if they even have an interest. Not everybody necessarily is interested in hosting a turbine on their property, so you need to find out if they're interested. And then the next thing you really need to look for is proximity to a major transmission line. Like the small rural or feeder lines really aren't sufficient to carry the electricity that's going to be produced by these turbines. So you need to find a much larger or transmission line that can service the grid. Obviously, our intent is to produce enough electricity to be put into the grid and then to service some of the larger load centers. As Rainey mentioned, Chicago's one, but certainly one of the larger load centers is the northeast portion of the United States. So some of this energy that we produce here might be used locally, or it might be shipped via the transmission lines out to the East Coast or other areas that have a large demand.
A question I've always had, and maybe too complicated to answer, how far can electricity be shipped? If you produce it in Champaign County, could it end up in Washington, D.C.?
The answer is yes. It can be shipped. It might not, it takes a lot of energy to move energy, so it might not be at the same rate that you had, but certainly you can move it both through transformers, having the power stepped up and boost it right on down the line.
Well, one thing about this new technology, and your company, of course, being fairly new, 6, 7 years old, is that you have to work with companies that have been around for a long time distributing electricity. The Ameren Silcos, the Illini Electric Cooperatives, the ComEd up in the Chicago area. How are these companies reacting to this new source of power? I'll ask you, Bill.
Oh, well, certainly they're very interested. In the state of Illinois, they have what's referred to as a renewable portfolio standard that's been enacted. So a certain percentage of our electricity needs to be produced from renewable sources. So many of the power companies are looking for those off-takers, or they're off-takers to us. We produce the electricity, they purchase it from us. So they need to meet those standards themselves. Obviously, there's some other legislative action in the United States that's leading towards potential carbon credits, things like that. So more and more you're going to be seeing large industries or large power companies purchasing renewable energy, and wind being one of those sources.
I'll ask Randy to answer this question. As you look at the government interaction, the power company interaction, and then entrepreneurial new companies that are producing these, how do you approach that to your students? Because some of those students may be in the position to help negotiate contracts or write legislation for elected officials on how this will all fit together. How are you guys approaching that from the academic side?
Well, that's a difficult area. Obviously, anytime you start talking about government policy, here we're sponsored by Farm Bureau, a long history of agricultural policy, it gets pretty sticky. But as I mentioned, one of the specializations in our major is the public policy and economic track. In that area, we specifically prepare students for that field because it is so critically important. Speaking of the grid, one of the hot topics these days is the so-called smart grid. And so as you talk about moving electricity around, the whole idea is to have a grid that is computer controlled and can sense where the deficits are going to be and where the surpluses are going to be, and automatically make those adjustments and tie not just states together, not just regions together, but in fact the entire United States.
That leads to a question. As we talk about oil and the big concern about foreign oil, importing of oil, in electricity, it doesn't work that way. This could not be transmitted overseas. I mean, there's no way electricity can go that far. Is that right?
That would be true. So we do ship some electricity into Canada, but for the most part, no, you're talking about a local market.
A domestic resource.
Produce it where you need it.
Interesting. All right. Well, that's an interesting side that people have to think about, that there's no such thing as foreign electricity as there is foreign oil. So a good point. Bill, let's talk about, this looks so green. This looks like it just has green written all over it, and I say green as far as environmentally friendly. Is there another side to that, or is it just as good? And I want to bring up slide number 3. We're going to bring up slide number 3, which kind of looks like on the beauty part of wind energy here. Tell us about the green part of a turbine out there, or is there any disadvantages?
Well, certainly the advantage is that you're producing electricity from a free source, which is the wind. Wind is naturally occurring. It's produced from differentiations in pressure, weather pressure. So, from that aspect, we think it's a very green and nice source of electricity. I will admit there are some people, there are a couple of things we always need to be careful of, and that is to properly locate a turbine, because they do make some noise. They aren't silent. So we need to make sure we have proper setbacks to homes. Also, there's what's referred to as shadow flicker, and it's the light that the sun is at an angle such that it's casting a shadow through the blades. Some people find that to be a little distracting. So again, with proper siting and proper locating of these turbines, you can alleviate most of those issues.
In rural America, of course, that's the main place. Is there ever such thing as a wind farm in an urban setting?
I'm not familiar with any that have been done recently. There are some turbines that are put up on buildings, and you're starting to see a little bit more of that. But on a large utility scale like this, no, not.
Randy, what about you? Do you guys ever see anything like that?
No, there's interest in what's called urban turbines, but that's again where I would throw up that caution. People talk about putting wind turbines on top of tall buildings. Capturing that idea that I mentioned, that the higher you go, the greater the wind. So, well, let's just put it on top of the buildings. But the record has shown that that's not really a very effective way, and there is a lot of concern about micro vibrations and long-term damage that might do to a foundation. The urban environment is such a difficult environment for the wind because of all the structures of different heights. It really creates a tremendous amount of turbulence, and that's not a good environment for generating electricity from wind.
However, out in rural areas, Bill, I'm sure you see that is not a big concern because of the open space aspect of the area.
Well, that's absolutely correct. I mean, the fact that you are in a rural area, there's very little adverse effect to the landowners or to people around it. And then, from the local standpoint, it's just it's an excellent additional income resource for the landowners. The farmers do generate annual payments off of the turbines. They could be anywhere from 20 to 40 years. So. Looking at it from that, it's a wonderful way for the local farmer to really benefit.
I'm sure that people watching the program today are saying, well, can the local farmer plug his house into that generator? Can he do that?
We don't allow that.
So I was afraid that wouldn't happen.
Their benefit is from the annual payments, but we're the process is for us to sell the electricity into the grid.
Very good. Well, gentlemen, I want to thank you so much for being with us. We've covered a lot of ground here. Hopefully, it's not been a lot of hot air. Excuse the pun. Had to put that in there somewhere. But I'm sure that both of you gentlemen, I appreciate your work in the academic world of training our new students to find out about. How can they find out more from Illinois State? Go to your website.
They can go to our university website. The major is within our Department of Technology. So if they go to that website, they can get a link to all of the program requirements.
Very good. Thank you for listening. I hope you learned something today about wind energy. Tune in again next time here on Champaign County Agriculture Today. I'm Dennis Riggs.
Champaign County Agriculture Today is brought to you by Champaign County Farm Bureau.